Antarctica is a lot warmer than it should be, with temperatures in the atmosphere above the continent soaring by over 35 degrees Celsius. It's no exaggeration to say the climate emergency has hit Antarctica hard. Welcome to The World, the Universe and Us from New Scientist. I'm Dr. Rowan Hooper.
And I'm Dr. Penny Sarche. In the Antarctic spring atmosphere, temperatures should normally be minus 55 degrees Celsius. But when we made this report, temperatures had risen to minus 20 degrees Celsius. And that meant that wind speeds in the stratosphere, the polar vortex, dropped by half to a comparatively calm 100 kilometres per hour.
Our climate reporter Madeline Cuff reported on this from a climate conference on Antarctica. And I started by asking her about the mood at the meeting.
It's fair to say that scientists are pretty worried about how quickly things are changing there.
They're always understated when they say they're worried, aren't they? Is that for the rest of us, it would be like
panic.
Total fear.
Yeah, I think red alarms flashing.
Yeah, red alarms flashing. It is an emergency in Antarctica. Let's start with the polar vortex, and that's what's been causing some weird weather and other conditions in Antarctica. And the vortex is this measure of wind speed in the stratosphere, and that normally traps really cold air above Antarctica. And if it slows down, that's when warmer air can get in, warmer weather can get in.
Yes, exactly. And it usually should be quite stable at this time of year. So kind of trapping cold air above the Antarctic continent. But there's some emerging evidence to suggest that it's changes to sea ice cover in Antarctica that is weakening the wind speeds of the polar vortex. And when you have weaker wind speeds, you can have these warm air intrusions that can deliver sudden spikes in temperature to the continent. My colleague James Woodford, who's based in Australia, has done a great story on the current weird conditions that we're seeing in Antarctica and what they mean for Australia's upcoming spring and summer. You can read that now over on New Scientist.
And you mentioned there that this all seems to be linked to changes in sea ice in Antarctica. That's the story at the bottom of all of this, is it?
Yes, exactly. That's one of the really big research themes that scientists looking at Antarctica have been covering, and what the conference I was at this week was really focusing on. So usually Antarctic sea ice peaks in September, which is the end of the Southern Hemisphere winter, and it retreats to a minimum in February. Now, since we started using satellites to measure sea ice extent, that was back in 1979, the pattern of ice cover in Antarctica has been pretty stable as compared to the Arctic, for example, where we've seen kind of rapid and steady loss of ice. But since 2016 in Antarctica, there's been a kind of sudden shift that scientists have been calling a regime shift, where we've seen a number of record low sea ice extents in the summer. And even in the last couple of winters, the maximum sea ice extent has hit record lows. 2023, in fact, was a record low minimum and maximum year. So a really kind of standout year for sea ice extent in Antarctica. And scientists are worried that this could suggest the continent has passed a tipping point of no return.
We're going to find out why that might be in a minute. But it is true, isn't it, that the Antarctic has been neglected compared to the Arctic. Maybe the changes have been more subtle and now it's suddenly catching up. But why is it so worrying about these changes in Antarctica? Let's reel back to that.
Yeah, sure. So unlike the Arctic, which is all ocean, Antarctica is a landmass that for most of the year is covered in both landline glaciers and surrounding sea ice. So the sea ice that surrounds the landmass helps to keep the ice that's on the land kind of locked away and safely frozen. And so it's not exposed to the warming and eroding forces that the ocean water would have. So if you get rid of the sea ice and expose the landlying ice to the water, then that dramatically increases the threat of catastrophic global sea level rise. We're talking tens and tens of meters. Then you've also got the albedo effect of the sea ice. So white sea ice reflects radiation while darker ocean waters absorb it. So if you remove the sea ice from Antarctica, the oceans will warm more quickly, and that will kind of accelerate future global warming. So it's a bit of a vicious cycle. And that's before we've even got to the impact on Antarctic ecosystems that rely on steady sea ice formation for their breeding cycles. So we've already seen, for example, mass mortalities in some penguin colonies because the sea ice is melting before the chicks can fledge.
And so you mentioned that sea ice formation really seems to have changed since 2016. Have researchers made progress in understanding why that shift, why that time?
Well, there's definitely now some consensus that this is well beyond what natural variability could look like and is therefore influenced by human-caused climate change. So at the conference I was at this week, Marilyn Raphael from the University of California presented some analysis, which basically her and her team extended the sea ice data from the satellite record that we have right back to the start of the 20th century with the help of using proxy data from Antarctic weather stations. And she concluded that based on this longer time series of historical data, the chances of seeing the record low sea ice extent that we did in 2023 is less than 0.1%.
Wow, it does seem another catch-up that we're only just being able to say that it's beyond the natural variability in Antarctica, where we've been able to say that for other systems years ago, that it's definitely a human-caused climate change. So do we know what exactly is happening? Is it like warmer air, or is it the warmer sea temperatures that's stopping the ice forming, like you were saying?
Yes, so we're beginning to get some answers about actually the processes that might be at play that are contributing to the sudden shift in sea ice formation. The main suspects that researchers are looking at is warming ocean temperatures. So usually there's a current of warmer deep water in the Southern Ocean that's known as circumpolar deep water, and this normally is kept pretty separate from the cooler surface waters, which means that sea ice can generally form without any trouble across the continent. But we now suspect that a combination of changing wind speeds and changes to the salinity of the ocean, how salty or not the water is allowing this warmer deep water to upwell towards the surface. So there's more mixing between the deep ocean waters and the surface waters. And because our oceans have taken up so much of the planet's excess heat over the last few decades, they've really borne the brunt of global warming. This deep ocean water is warmer than it should be, and that means that the sea ice can't form in the way that it should do to the same extent.
And this does sound like one of those things that once it's changed, you can't change it back.
Yes, changes to ocean circulation are generally pretty difficult to reverse. One of the big outstanding questions is whether or not we have triggered a kind of tipping point in the way the Southern Ocean works and the way sea ice formulates around Antarctica. One of the big uncertainties when we think about whether or not we could reverse this change in the future is how ocean circulation patterns might respond to the future melt of glaciers. So if you think about it, if you dump a whole load of fresh water from melting Antarctic glaciers into the ocean, you could essentially put a lid on this upwelling effect, and the fresh cold water would suppress this upwelling impact and you would re-stratify the ocean. But we still don't really know if this would happen, the timescales at which this would happen, and crucially, it would still bring a huge amount of sea level rise for everybody else in the world, even if it did work to stop future ice melt.
Yeah, that uncertainty is such an awful thing, and it just casts a huge amount of doubt and gloom over everything. I asked Edward Doddridge about this. He's an oceanographer at the University of Tasmania. He works on modelling Antarctic currents, and here he is on that.
While each of these changes is concerning in its own right, my biggest concern is that we are starting to see changes cascading through different parts of the Antarctic environment. Sea ice loss in the summer enhances the breakup of ice shelves and causes ocean warming. These warmer ocean waters melt the remaining ice shelves faster, releasing fresh water that slows down the Antarctic overturning circulation. Each of these changes builds on and potentially reinforces the others. I wish I could say that we know what will happen next, but the truth is that we don't. Our scientific knowledge is always expanding, but Antarctica is changing so rapidly that we are struggling to keep up.
Antarctica is changing so rapidly, we're struggling to keep up.
And that's why it's a climate emergency.
Thanks for watching The World, the Universe and Us. Do hit subscribe to make sure you don't miss out. I'm Dr. Rowan Hooper.
And I'm Dr. Penny Sarte. See you next time.